we're going to look at one more example for elimination. And in this example, what I notice right away is that the two equations, they're not set up the same exact way. For the first equation, I notice that the x and y terms are on the left. But then in the second equation, the y term is on the left, and then the x term is on the right. Right? So in order to do elimination, we need the equations to be set up the same way. So I'm going to do that by changing the second equation. Right? And in order to do that, I'm going to add 6x to both sides. So add 6x to the right and to the left. And that's going to give me this equation here. 6x minus 5y is equal to 3. All right, let me rewrite our problem here. All right, so our first equation didn't change. It's 4x minus 7y equals 13. And then the second one, we have this, 6x minus 5y equals 3. All right, so this equation, this system here, it's equivalent to this one, right? All we did is just change the way that this was set up, right? All right, so now we're ready to do our elimination. All right, and so remember, what we want to do is we want to get either the x terms or the y terms to have opposite coefficients so that we can add the two equations together and one variable will be eliminated. All right, and it does not matter. You can do it with the x's or with the y's. I think in this case, I'm going to do it with the x's. All right? So I want you to think, what could I multiply these equations by so that they will have opposite coefficients? All right? Pause and think for a second. What would we need to multiply so that we would have opposite coefficients? All right, there's more than one answer, but what I'm going to do is I'm going to multiply the top equation by positive 3. And I'm going to multiply the bottom equation by negative 2. Why does that work? Well, if I multiply these two, 3 times 4x, that's going to give me positive 12x. And then on the bottom here, negative 2 times 6x is going to be negative 12x. So those will be opposite coefficients. All right, so here's what we'll have. We'll have, for the first equation, we'll have 12x minus 21y equals 39. For the second equation, we'll have negative 12x plus 10y equals negative 6. Again, right here, this is what we want. We have positive 12x, we have negative 12x. We want them to have opposite coefficients. All right, so now let's add these equations together. All right, and we have negative 11y equals positive 33. And then if I divide both sides here by negative 11, we get y is equal to negative 3. Okay, not quite done yet. We need to get our x value. Right, and I'm going to go ahead and substitute this y value into one of our original equations. Right, that's a good piece of advice. Always substitute back into one of the original equations. All right, so sorry about that. Let's try that again. Let's substitute that into how about the first equation? We had this 4x minus 7y equals 13, and so we have 4x minus 7 times my y value. Y value was negative 3. So now I have 4x plus 21 is equal to 13. Okay, next, let's subtract 21 from both sides. Now we have 4x is equal to negative 8. And then if I divide both sides by 4, we get x is equal to negative 2. So our final answer is the point negative 2 comma negative 3. Okay. And just as a reminder, what does this mean? This is the ordered pair that when we plug it into both of these equations, right, it would make both of those equations turn into a true statement. Also, this point here, this is the place where the two lines would intersect if we were to graph these two lines.